In this video, we'll discuss problems and conceptual exercises of chapter 3 from the book James S. Walker. Now in this question we are given with two vectors. Vector A we have minus 3.8 x cap and vector B we have 2.1 y cap. Now what they are asking is the magnitude of A plus B vector is greater than, less than or equals to the magnitude of A minus B vector? And three options we are given. We have to choose the best explanation. Now if you see these two vectors carefully, these two vectors are perpendicular to each other. It's in the x direction and it's in the y direction, so they are perpendicular to each other. Either you add the vectors or you subtract the vectors, it will form a right angle triangle, and the hypotenuse will be the vector sum and the vector difference of these two vectors. So the length of the hypotenuse will remain same independent of its direction. So we can say that the magnitude of this A plus B vector, let me write here, the magnitude of A plus B vector should be equals to the magnitude of A minus B vector. So this is for the A part. Now next, in the B part we have to choose the best explanation. First part, it says that a vector sum is always greater than a vector difference. This statement is totally wrong, because vector sum is not always greater than the vector difference, so this is false. Next it says that A plus B and A minus B produce similar triangles because A is perpendicular to B. This statement is true, and this is the correct statement for this question. Now let's read the third statement also. The third statement says that the vector minus B is in the same direction as A vector. So this is also wrong, because minus B is in the negative y direction and A is in the negative x direction. This is also wrong. So this should be the correct answer. So this is our next question, and it's a very easy question. We have seen multiple questions like this, so I'll be just writing the answers. You can do on your own, and if you have any confusion you can comment in the comment box below. So vector A we are given this thing, and vector B we have this thing, and we have to find the magnitude and the direction of 2A plus B. Okay, so the magnitude will come out to be as, I'm just writing the answers because it's a pretty simple question and we have solved multiple questions like this. This would be the magnitude, and the direction theta, this would be minus 53.1 degree. Why this negative? Because the direction is below the x-axis, or you can write 307 degrees. So this would be the answer for this question. Now in this question we are given that the component of a vector B satisfies Bx greater than 0 and By less than 0. Bx greater than 0 means it is along the positive x, so this should be the direction for Bx, and By less than 0 means negative y, so this should be By. Now we have to tell, is the direction angle of vector B is between 0 to 90, 90 to 180, 180 to 270, or 270 to 360. Now from this diagram we can say that B should be in this direction. This is the vector B, and these are its components Bx and By. Now we know that we always measure angle in the anti-clockwise direction from the positive x, so this should be the theta, and this is our fourth quadrant, and in the fourth quadrant theta ranges from 270 degrees to 360 degrees. So this should be the correct answer for this question. Now in this question we are given that you pilot an aeroplane with an intent to fly 392 kilometers in a direction 55 degrees south of east from the starting airport. Now suppose that this is our origin and this is your starting point. So you intend to fly 392 kilometers in a direction 55 degrees south of east. So you want to fly like this, and this angle we are given to be 55 degrees. This is our east direction and this is our south direction, right? Now but the ATC, the air traffic control, requires you to first fly due south for 85 kilometers. So what the ATC wants, it wants that you should first fly like this for 85 kilometers, and after completing 85 kilometers you can fly to your final destination. So you'll fly something like that. Now what we need to tell in the A part, after completing 85 kilometers due south, how far are you from your destination? So let this be your final vector R final. This is your R1 vector and this is the R2 vector. So what basically we need to find? The magnitude of R2 vector, because this distance you need to fly to reach your final destination. So if you calculate this R2 vector, we can easily find this magnitude. Fine. So now by using the concepts of vector addition, we can write that R final, this should be equals to R1 plus R2, and from here vector R2 would be equals to vector R final minus vector R1. Now I'll be writing the components of this R final. Now this angle is 55 degrees and this is in the clockwise direction. So actually we can take theta to be minus 55 degrees. So because we are measuring in the clockwise direction, so R final, this would be magnitude, we have 392 for R final. So this should be 392 cosine minus 55 degrees plus 392 sine minus 55 degrees. Then minus, and this R1 we have it's along the negative y. So and I just forget to write one thing here, the unit vector. So here it should be x cap and here it should be y cap, right? Now next this is, we have minus 85 y cap. Why this is minus? Because it's along the negative y, right? Now we can solve it further. So we'll get vector R2, this would be equals to, now this would become 225 kilometer x cap, and this would become minus 321 kilometer y cap, and finally this minus and this minus would become plus, so plus 85, this is in kilometer y cap. Now we can add the y components. So R2 vector, this would be equals to 225 kilometer x cap as it is, and this would become minus 236 kilometer y cap. Now we can easily find the magnitude of vector R2. So R2, this would be equals to under root 225 and it's squared plus minus 236 and it's squared. So on solving this we'll get this value to be 326 kilometer. So this would be the answer for the A part. Now next, in the B part, we need to find in what direction should you point your plane to complete the trip. So basically we have to find the theta. So theta, we know it's pretty simple. Theta is tangent inverse the y component over the x component. Y component we have minus 236 kilometer and the x component we have 225 kilometer. So on further solving this, we'll get this value to be minus 46.4 degrees. And why this is negative? Because it's below the x-axis. Or we can write that it is 46.4 degrees south of east. Let me show it on the figure also. So actually this is, if you take this as, so this would be theta, which we have calculated to be 46.4 degrees. Okay. So this is the answer for the B part. Now next, in the C part, we need to find that if the average if the average ground speed is 485 kilometers, what estimated time of travel should you give to your passengers? Okay. So your speed for the aircraft, for the airplane, is 485 kilometer. So time taken to cover this much of distance would be, time is distance over speed. Distance we have 326 kilometer, and average speed we can take it to be 485 kilometer per hour. So this comes out to be as nearly 0.672 hour. This much of hour. Now if you convert it into minutes, we have to multiply it with 60, because 60 minutes is equivalent to 1 hour. This hour and hour will cancel and we'll get the answer in minutes, and the answer would be nearly 40.3 minutes. So this much of time you'll require to reach to your destination. So this would be the answer for the C part. Now in this question we are given that observer 1 rides in a car and the car is traveling in the horizontal direction with a speed of 3.50 meter per second. Now the observer 1 drops the ball from rest straight downward relative to the interior of the car. So this would be the velocity of the ball relative to car. So we can take it to be C. So this is the velocity of the ball relative to car. Now here this is the observer 2 who's standing on the sidewalk and he's seeing all this which is happening in front of him. Now in the A part, what they're asking is the speed of the ball 1 second after it is released as measured by the observer 2. Now observer 2 is standing on the ground, so we'll be calculating the velocity of the ball relative to ground, and the magnitude of this velocity will tell you the speed. Now let's try to figure out the vector diagram. So this is the velocity of the ball relative to car, which is directly downwards as per the question. Now the car is running in the horizontal direction, so this would be the velocity of the car relative to ground, and its magnitude we are given to be 3.50 meter per second. Now from the relative motion concepts, we can write that the velocity of the ball relative to ground, this will be equals to velocity of the ball relative to car plus the velocity of the car relative to ground, and the direction of this velocity and this velocity we know. This is VCG and this is VBC. So sum of this vector will be given by, pretty simple, by this vector, right? Now we know the magnitude of this VCG, but we don't know the magnitude of VBC. We just know the direction. So we'll be calculating the magnitude first. So what it says that the ball is dropped from rest, so its initial velocity will be 0. So V naught, it would be 0. Now we need to find the speed after 1 second. So time we have to take it to be 1 second. And after the ball is dropped, the ball is in free fall. And we know when the object is in free fall, the acceleration is acceleration due to gravity. And its value we know it is 9.81 meter per second squared. Now we're going to use the equations of motion to find the velocity of the ball after 1 second. So we have V naught plus 80. Now V naught we have 0. Its initial because it's dropped from rest, so V naught would be 0. Plus now acceleration is acceleration due to gravity, and since G is in the downward direction and we have taken this to be our positive Y, so we should take it to be minus G times T. Now we can put the values. G is 9.81 meter per second squared, multiplied with time we have to take it to be 1 second. So this would be equals to, so I should put a negative sign here, so minus 9.81 meter per second. So this is the velocity and it's in the negative y direction, so we can put it to be the y cap here. So this is a vector BC, velocity of the ball relative to car. Now we have all the values. We can put all the values here. So VBG, this would be equals to VBC, we have minus 9.81 meter per second y cap, plus VCG, we have this is 3.50 and it's along the x direction, so we can multiply to the unit vector x cap. So this is 3.50 meter per second x cap. Now the magnitude is pretty simple. The magnitude of the velocity would be equals to under root the x component square plus the y component square. X component we have 3.50 and it's squared. This is minus 9.81 and it's squared. And on solving this, we'll get this value to be 10.4 meter per second. So this is the answer for the A part. Now in the B part, we need to find the direction of travel of the ball 1 second after it is released. So basically we have to find this angle theta. So it's pretty simple. Theta would be equals to tangent inverse the y component over the x component. Y component we have minus 9.81. So minus 9.81 divided by 3.50. Now you can use your calculator to find the answer, and we'll get this answer to be theta to be minus 70.4 degrees. And why this is minus? Because it is below the x-axis. So this angle is 70.4 degrees. Or you can write in another way, we can write this is 70.4 degrees below the horizontal. So this would be the answer for the B part. Now here we see that the observer 1 and observer 2 describes the motion of the ball differently. Here you can see that for observer 1 the ball is moving straight downward, but with respect to observer 2 the ball is moving like this. This green arrow will show this direction. This is VBG. So with respect to two observers, the motion is totally different, and this forms the foundation of Einstein's special theory of relativity that we'll explore in more detail in the coming seasons.